In the world of programming, repetition is key. It's a fundamental concept that allows us to perform tasks efficiently and effectively. Without repetition, many of the tasks we take for granted in the digital world would be incredibly time-consuming and prone to error. Loops are the programming structures that allow us to execute a block of code multiple times. They are the backbone of repetitive tasks in programming, enabling us to handle large amounts of data and perform complex operations with ease. This is essential for automating tasks, processing data, and building complex logic. Imagine having to manually process thousands of data entries. It would be an overwhelming task. Loops simplify this by automating the repetitive actions, making our code more efficient and less error-prone. Python, known for its readability and efficiency, provides powerful looping constructs like for and while loops. These constructs are designed to be intuitive and easy to use, allowing programmers to write clear and concise code. These loops, combined with Python's built-in data structures, make it remarkably easy to work with repetitive tasks. Whether you're working with lists, dictionaries, or sets, Python's loops can handle them all with grace and efficiency. Imagine you have a list of names, and you want to print each name individually. This is a common task that can be easily handled with a loop. Instead of writing a print statement for each name, you can use a loop to iterate through the list and print each name in turn. Doing this manually would be tedious, especially for a large list. Manually writing out each print statement would not only be time-consuming, but also increase the likelihood of making mistakes. Loops eliminate this tedium and reduce the risk of errors. Loops come to the rescue, allowing us to automate this process with a few lines of code. This not only saves time, but also makes our code more maintainable and scalable. As the list grows, the same loop can handle the increased data without any changes to the code. This essay will guide you through the world of loops in Python. We'll start with the basics and gradually move on to more advanced concepts, ensuring that you have a solid understanding of how loops work and how to use them effectively in your programs. We'll explore different loop types, how to control their execution, and how to iterate over various data structures. You'll learn about for loops, while loops, and even nested loops, which allow you to perform more complex iterations. Whether you're a beginner just starting with programming or an intermediate learner looking to solidify your understanding, this guide will provide you with the knowledge and tools to master loops in Python. We'll cover common pitfalls and best practices to ensure that you can write efficient and effective loops. So let's dive in and unlock the power of repetition. By the end of this guide, you'll have a deep understanding of loops and how to use them to make your code more efficient, readable, and powerful. Let's get started on this journey to mastering loops in Python. The for loop is the most common loop in Python. It's used to iterate over a sequence of elements such as a list, tuple, dictionary, set, or even a string. This versatility makes it an indispensable tool in a Python programmer's toolkit. Executing a block of code for each element in the sequence, the for loop allows for efficient and readable code. Whether you're processing data, automating tasks, or performing repetitive operations, the for loop is your go-to construct. The syntax is simple and elegant, making it a favorite among Python developers. Its readability and straightforward nature mean that even beginners can quickly grasp its usage. Let's break down the syntax. The for keyword initiates the loop. This is followed by a variable name, which will take on the value of each element in the sequence during each iteration. The in keyword separates the loop variable from the sequence. The colon marks the beginning of the loop's code block. Here's an example of a for loop that prints numbers from 0 to 4. For I in range, 5, print I. This loop will print the numbers 0, 1, 2, 3, and 4. The range function generates a sequence of numbers from 0 to 4. In each iteration, the variable I takes on the next value from the sequence and the print statement executes, displaying the value. The for loop is not limited to just numbers. You can iterate over any iterable object. For example, you can loop through a list of strings. Fruits equals sign, apple, banana, cherry for fruit and fruits, print fruit. This loop will print each fruit in the list, apple, banana, and cherry. The for loop's ability to handle different data types makes it incredibly powerful. You can also use the for loop to iterate over the characters in a string. For char in Python, print char. This loop will print each character in the string Python. Python. The for loop's flexibility extends to more complex data structures as well. For instance, you can iterate over the keys and values in a dictionary. student underscore grades equals sign, Alice, A, Bob, B, Charlie, C for student, grade and student underscore grades dot items, print student grade. This loop will print each student's name and their corresponding grade, Alice A, Bob B, Charlie C. The for loop's versatility and ease of use make it a cornerstone of Python programming. Whether you're working with simple lists or complex data structures, the for loop provides a clear and concise way to iterate over elements and perform operations on them. Understanding and mastering the for loop is essential for any Python developer, as it opens up a world of possibilities for efficient and effective coding. So the next time you need to repeat an action or process a collection of items, remember the power and simplicity of Python's iteration workhorse, the for loop. While for loops iterate over a sequence, while loops provide more control over the loop's execution by repeating a block of code as long as a condition remains true. The syntax for a while loop is, while condition, the keyword initiates the loop. The is a Boolean expression that is evaluated before each iteration. If the condition is, the code block within the loop is executed. This process continues until the condition becomes. Here's an example of a while loop that counts down from 5 to 1. Countdown equals sign 5 while countdown 0. Print countdown, countdown, equals sign 1 print, blast off. In this example, the loop continues as long as the variable is greater than 0. In each iteration, the current value of is printed and then it's decremented by 1. Once reaches 0, the condition becomes and the loop terminates, printing blast off. The function is a handy tool often used with loops to generate sequences of numbers. It's particularly useful when you need to iterate a specific number of times or over a specific range of values. The function can be used in 3 ways. 1. Generates a sequence of numbers from 0 to. For example, generates 0, 1, 2, 3, 4. 2. Generates a sequence of numbers from 2. For example, generates 2, 3, 4, 5. 3. Generates a sequence of numbers from 2, incrementing by. For example, generates 1, 3, 5, 7, 9. Here's an example demonstrating the use of with a for loop to print even numbers from 1 to 10 Python for I in range, 2, 11, 2, print I. In this example generates the sequence 2, 4, 6, 8, 10. The loop iterates over this sequence and the statement displays each even number. Python provides several statements to control the flow of execution within loops, allowing us to skip iterations or exit a loop prematurely. These statements are essential for writing efficient and effective code, especially when dealing with large data sets or complex logic. The first statement we'll discuss is the break statement. The break statement is used to exit a loop prematurely, regardless of the loop's condition. When encountered, it immediately terminates the loop's execution and continues with the code after the loop. This can be particularly useful when you need to stop processing as soon as a certain condition is met, saving time and resources. Next, we have the continue statement. The continue statement is used to skip the current iteration of the loop and move to the next iteration. It's helpful when you want to avoid executing certain code within the loop under specific conditions. For example, you might want to skip processing certain values that don't meet your criteria, allowing the loop to focus only on the relevant data. Delve deeper into each of these statements with more detailed examples and scenarios. The break statement can be particularly useful in search operations. Imagine you're searching for a specific item in a list. Once you find the item, there's no need to continue checking the rest of the list. By using the break statement, you can exit the loop as soon as the item is found, making your search operation more efficient. Here's an example. numbers. The pass statement, while seemingly trivial, can be quite handy during the development process. It allows you to write code that is syntactically correct, but doesn't do anything desired results with ease.